and welcome. Today we're going to be talking about section 12.5, scale drawings. Under our key idea, we can read that a scale drawing is a proportional, two-dimensional drawing of an object. Basically, that means it's either a smaller or a larger version of the real thing. A scale model is a proportional, three-dimensional model of an object. The definition of a scale. The measurements in scale drawings and models are proportional to the measurements of the actual object, meaning we either multiplied or divided by a constant amount. The scale gives the ratio that compares the measurements of the drawing or model to the actual measurements. For example, if you have a map, and on the map the drawing distance is 1 inch, this scale tells us that the 1 inch on the map represents 10 miles in real life. You may also write that in this form, where 1 inch still represents 10 miles in real life. In example 1, we're going to go ahead and find the distance between Cadillac and Detroit. So Detroit is down here on the bottom right of my map, and Cadillac is here more towards the middle of my map. I'm going to go ahead and get out my ruler and measure the distance between these two cities. On my ruler, I see that from Cadillac to Detroit, it's about 5.5 centimeters. The reason I'm measuring in centimeters is because my scale in the top right-hand corner of this map says that 1 centimeter represents 50 miles. So if I know that 1 centimeter represents 50 miles, all I need to figure out is how many miles 5.5 centimeters represents. So I'm going to go ahead and write a proportion. My scale says that 1 centimeter represents 50 miles. Here's that ratio. But to create a proportion, I'm going to go ahead and let that equal the distance I have on my map, which is 5.5 centimeters. And I'm going to let that be over the distance in real life, which we're going to call d. Now to solve for that distance, I'm just going to cross multiply. D times 1 centimeter is just d centimeters. That's going to be equal to 50 miles times 5.5 centimeters, which is 275, and then our units are going to go ahead and follow. I have both centimeters and miles here, and we are multiplying. Now the only thing I need to do to get this distance by itself is solve for d by dividing by my units of centimeters. Divide by those units on both sides. And what we end up finding is that d is going to be equal to 275 miles. Therefore, the distance from Cadillac to Detroit is 275 miles. And that would be our final answer in the form of a sentence. For the On Your Own question number 1, I'm going to go ahead and measure for you the distance on the map from Traverse City to Marquette. So on the map, if I take my ruler and find Marquette, which is up here now in the top left, and go to Traverse City, which is towards the middle of the map, I see that it's about 4.75 centimeters. If I'm measuring on my ruler, from 0 to 4.75 is about the distance between the two cities. So on the map, I see a distance of 4.75 centimeters. I'd like for you to now go ahead, pause the video, and see if you can create a proportion like I did above to solve for the actual distance between the two cities. What I found is that the distance d between the two cities is 237.5 miles. And then, of course, you would take this answer and write it in a complete sentence. For example 3, the question is asking, A scale model of the Sergeant Floyd Museum is 10 inches tall. The actual monument is 100 feet tall. What is the scale of the model? So 10 inches in the model, that 10-inch height represents actually 100 feet. So this is my scale. I can go ahead and reduce that down to 1 inch, representing 10 feet. The scale has actual units in it. A scale factor does not. The scale factor says, what would you multiply the larger one by to get the smaller one? Or what would you multiply the actual by to get the model? So in order to figure that out, I need to go ahead and change all of these units into the same unit and then reduce. To make things a little bit easier, I'm going to change into inches. Feet is much easier for me to change into inches. So I have 1 inch representing 10 feet. But instead of 10 feet, I know that 10 feet is equal to 120 inches because there are 12 inches in every foot. And if I have 10 feet, that means I have 12 tens. So this is going to become 1 inch over 120 inches. And now that I have those units repeated in both the numerator and the denominator, I can reduce them out of my fraction, and what I end up with is a scale factor of 1 over 120. So what we have found is that the model of the actual monument is 1/120th of the height. This is our scale factor. Example 4. The scale drawing of a computer chip helps you see the individual components of the chip. Find the perimeter and the area of the computer chip in the scale drawing. I'm going to go ahead and get out my ruler again to measure this scale drawing. So we know that 1 centimeter in the picture represents 2 millimeters in real life. So in my picture, if I measure, I see that the bottom of this computer chip is about 5.5 centimeters. So in my drawing, this computer chip has a length of 5.5 centimeters. Since we're trying to find the area and the perimeter, I'm also going to measure the height of my computer chip. So I'm going to turn my ruler, bring this up to measure the height, and it is also about 5.5. So then I can conclude that this computer chip is a square. Now that we know that the length and the height of this figure are 5.5 centimeters in my drawing, I can easily find the area. 5.5 I'm going to use for both the length and the width. Plugging those into my formula for the area of a rectangle or a square, I've got 5.5 times 5.5. And I'll let you do that math. For the perimeter, I know that it's equal to 2 times the length plus 2 times the width. So that means that the perimeter is 2 times 5.5 plus 2 times 5.5. And I'll go ahead and let you do those calculations as well. Once you find those, I'd like you to go ahead and challenge yourself to find the actual perimeter and area of the computer chip using the scale given. Go ahead and talk about it with your table, and we'll pick up here tomorrow. Have a great rest of your day.